So hello everyone and welcome to my final demo. Today we are going to explore something very simple but very practical. Uh, a simple calculator using Spring Boot. A simple uh, a simple calculator API using Spring Boot. So since this is my last demo, I have decided to do a simple topic. Now at first glance a calculator might seem trivial. We all know how to add, subtract, multiply and divide numbers. But what we are doing here is significantly different. We are turning the basic functions into a web service that anyone can access over the internet or on a local server. Think of it like this. Imagine a physical calculator on your desk. You press buttons and it gives you result. Now imagine if we wanted many people in different locations to use the same calculator at the same time. We can't physically give everyone the same device. Instead, we can uh, expose our calculator over the web. That's exactly what an API does. It allows anyone with a computer or application to send and request and get responses, just like using a calculator remotely. This approach demonstrates some fundamental concept of modern web applications, abstractions. Fundamental concepts such as abstractions. User don't need to know how to calculate works internally. They just send two numbers and operations and they get the result. The reusability. Once we build the API, we can reuse it in multiple applications. Maybe a mobile app, a website, or even another service without rewriting the calculation logic. Scalability. If we wanted many people could use our calculator simultaneously in a real world scenario, this is what happens with the web service like Google Map or payment gateways. They handle thousands of requests every second. Now, why we use Spring Boot for this? Spring Boot provides a lightweight and easy way to expose our functionality as RESTful endpoints. Instead of worrying about the underlying server setup and boilerplate code, we focus on what the application does. In this case, performing calculation, Spring Boot takes care of the plumbing, handling HTTP requests, sending responses, and managing the application's lifecycle. Let's also consider the practical relevance of a simple calculator API. You might think, why build this when I have a calculator in my phone? Well, the purpose isn't just about doing arithmetics, it's about understanding how services work over the web. By building even a simple API, we learn how to accept inputs from user and application, processes through input according to the business logic, return meaningful response in a structured format. These principles are exactly the same for large complex systems, whether it's an online banking API, a weather service, or a e-commerce platform. So starting with a simple calculator gives us a safe, understandable playground to explore these ideas. Let's think about the operation themselves. Add, subtraction, multiplication, division. These are simple, but they give us an opportunity to handle different types of input and result. For example, division introduced the concept of edge classes, like edge cases like dividing by zero. In the real world application, handling such edge cases correctly is crucial. It teaches us the application anticipate error, validate inputs, and respond gracefully. Exactly what professional application must do. Another interesting aspect is inter interaction with clients. Our calculator API isn't meant to be used by humans typing numbers directly. It's meant to be used by other programs or tools. This could be a mobile app, a web front end, or even a Postman for testing. This demonstrates how software communicates over network, which is the backbone of modern computing. Finally, this demo also highlights the importance of simplicity and clarity. Even a small API can show core principles of web development, endpoints, request, parameter responses, and error handling. It allows us to focus on learning the core concept without being distracted by unnecessary complexity like database or user authentication. So in this demo, while the calculator operations are simple, the idea behind them, web communication, API design, input validation, and reusability are fundamental skills for app development. By understanding this principle, with a simple example, we prepare ourselves for much bigger projects in the future. So by the end of this demo, you will see how a few lines of code can turn a simple idea into a working web service, and you will appreciate how Spring Boot simplifies web development, letting you focus on logic and functionality rather than boilerplate demo setup. In short, this demo is small in scale but big in concept. It's a perfect final demo to wrap up our series and demonstrate the practical use of Spring Boot in an understandable way. So before moving further into the demo, first we need to create a basic Spring Boot configuration initial files. For that we will require for our simple calculator project. For that we will require to go to the Chrome browser and search Spring Initializer. So this is a basic step in creating every Spring Boot project. First we need to initialize our project and add dependencies. So we don't need to create boiler plate files. This is the most exciting part about Spring Boot. It makes our work much easier. So let's configure our project. We will use language Java, project Maven. We will select version 3.5.4. uh, Project metadata. We will let the group be com.example and artifact or name. So we will change our project name. We will give project name simple calculator. uh, we will select packaging jar and Java version 17. As I have Java version 17 installed in my computer, to check Java version, go to command prompt and type command Java. So you need to type command Java version. So we will type command like this: Java hyphen version. So this tells me that I am having Java 17 installed in my machine. So for that reason, I will tick on Java 17. I will add dependency. So I will add Spring Web dependency because we will be using RESTful API in our project. And now I'll click in generate file. So this will download our zip file. So we need to extract this zip file in our workspace folder. So my workspace in D drive, demo practice. I will create a new file here. I will call it simple calculator, and inside this I will extract that zip file. So click on extract all, browse to D drive, uh, your project workspace file. So I will do an adjustment here. uh, there are multiple files inside each other. So this way we have our simple calculator project in there in D drive, demo practice simple calculator. Now we need to import this project in HTS4. For that, we will open our STS4 IDE software. Go to import, select existing Maven project. In root directory, browse to your folder, which is in D drive, demo practice, simple calculator. Select, make sure that pom.xml is ticked and click. So where project is importing. So once our project is imported, let's expand and take a look inside it. So we have our main package and our main class with @Spring Boot application annotation. We have a resource.application and we have pom.xml dependency file. So now let's dive into the coding part of the project. So first we will create a new calculator controller package. So right click on our main package, go to new package and name this package controller. So inside the package controller, we will create a new class for our calculator code. So right click on controller package, new class, and we will name this class calculator controller. Controller. After finishing this, I will copy paste the calculator code that I have already written. So I will import this libraries by clicking on the annotation and pressing Ctrl plus space. I also need to add the REST controller annotation, which basically tells Spring Boot that this particular class is used to handle the HTTP request. So now I will briefly explain you this code. So now we are going to dive into the main part of our simple calculator API, the calculator controller. A controller in Spring Boot is a calculator controller. So the controller in Spring Boot is basically the traffic cop of our application. It decides how incoming request from user and handled and what responses to send. Back whenever someone access a specific URL, the controller is the piece of the code that takes the request, performs some logic and return the result. In our case, the logic is very simple. It's a basic arithmetic operation: addition, subtraction, multiplication, and division. But even though it's the simple, controller shows us how endpoints works, how parameters are passed, and how responses are generated. This controller is annotated with REST controller. This is a special Spring Boot annotation that does two things. It tells Spring that this class will handle HTTP request, and it also tells Spring that the method will return data directly to client using as plain text as JSON without needing extra configuration. So inside the controller we have four methods, each handle a different operation. Let's start with the first one. So first we get get mapping add. This annotation maps HTTP GET request to this method. Think of it like an assigning a specific URL to a specific function. Whenever someone goes to the URL HTTP localhost 8080 add, this method gets triggered. The next part is the annotation at the request farm double and request farm double A and double B. These are how Spring Boot captures the number that user wants to operate. For example, if the user types the URL and he wants to give a is equal to 5 and b is equal to 3, Spring automatically extract 5 as a and 3 as b. This is very convenient because we don't need to press string or worry about input formats. Spring does it all for us automatically. Then the method is itself simply returns a string showing the operation of the result. So for addition it returns 5 plus 3 is equal to 8. Notice how readable and straightforward this is. No extra setup, no manual response building. Spring handles that. So in the subtraction method, the second method is subtract. It works exactly like add, but it performs a minus b. URL mapping is subtract. Query parameter a and b. Response, a string shows the subtract operation. For example, if we visit http localhost 8080 subtract, a is equal to 10 and b is equal to 4, this method returns 10 minus 4 6. Even though it's almost identical to the addition, uh, this repetition is good way of showing how you can define multiple endpoints in a single controller, each doing its own logic. It's also a great way to explain the identity of modularity, explain mode handles and single responsibility. Next method is multiplication. Next is multiplication. Again, the structure is the same. Get mapping multiply parameter a and b and result return result as a string. The formula is a into b. So if we test with the URL, the response is example 6 into 7 42. At this point we can pause and emphasize a key concept. So Spring Boot handles repetitive structure really efficiently. Even though we have four methods, the pattern is identical. Define the mapping, exactly the parameters, perform the operation and return the response. This keep the code clean and maintainable. Division method and cottage handling. So this is the final method, division method and edge case handling. The fourth method is divide. This is slightly more interesting because the division introduced the possibility of an edge case handling divide by 0. So the URL mapping is divide. Parameters are A and B. So we added a simple logic here. We check if B is equal to 0 and return the friendly error message division by 0 is not allowed. If b is not 0, we perform the division a divided by b and return the result as string. Edge cases are very important in real application. Even though a simple calculator seems basic, handling invalid or unaccepted inputs is a crucial skill. It teaches us robust coding practices which are essential for professional development. So even though the control is small, it demonstrates several concepts of Spring Boot and web development. REST endpoints. Each method responds to specific URL query parameters using a request form. We accept input dynamically. Clean code. Each method has a single responsibility. Response handling. Returning a string is enough for simple result. Edge case handling. Divide by 0 shows basic validation. These principles are exactly the same for larger, more complex APIs. The only difference is that real-world applications may involve database security and more advanced response structures like JSON, but the foundation is the same. When we run this application, the endpoints and test the endpoint using Postman. It's very interactive. User can type any number they want in the URL. The controller immediately returns the correct result. We can test edge casing, experiment with negative numbers and decimals. So this makes the demo visualize engaging and easy to understand, which is perfect for uh, so in summary, the calculator controller is simple but powerful example of Spring Boot explosion functionality over the web. It teaches us how to create REST endpoints, handle input parameters, return responses, and think about edge cases, all while keeping the code clean and minimal. Even a basic calculator demonstration demonstrated the core principle that underpin modern web application. Now, once we have done with writing code and I have explained the code, I will run this project. To run this project, click on your project, simple calculator, go to run as and select option. First do a clean package. After doing clean package feed get a build successful. This means there was no compilation error in our project. Now we will actually run our Spring Boot app. For this, right click on simple calculator, go to run as, select maven build and type command spring hyphen boot colon run, spring hyphen boot colon run, and click on run. So we can see we have successfully run our program with no error. Here we can see starting simple calculator using Java 17, our version, and the location of our project. Next, we have no active profile set falling, but so we have not created any profiles here. This next we can see Tomcat initialized with port 8080. So our project is running on port 8080. While typing the URL, we need to specify the port 8080 in the URL. It's next says starting service Tomcat, which is the server. Next says starting servlet engine Apache Tomcat. Initialize Spring Boot embedded web application. And finally we can see started simple calculator application uh, in 1.7 second the time it takes to run the application, and our application is currently running. Now let's test our application using Postman, a different URL. We will go one by one and check. So now that we have our calculator API is ready, let's see how we can test it in using Postman. Postman is a tool that allows us to simulate requests from user and other applications to our API. Think of it as a way to talk to our API without writing any front-end code. We send a number and operation and the API responds with the result. This step is important because in real-world application, developer, testers, and even other services need to verify that API behavior is correctly. So testing is just as important as writing code. So now we will open our Postman application, Postman software. So let's start with the first addition endpoint. In the Postman, we select the method get, and in the URL we type the URL http colon slash slash localhost our port number which is default 8080, and the URL configure location which is add. And now we will add two numbers. So for that, click here under the key, give a variable a and specify the value for a 5, give the variable b and specify the value for b 3. It is automatically done it in the error. So now when we hit send, we have got a 4040 error, which means it has not found add in our code. So let's try to terminate the process and run again. Let's see if it works this time. So what happened is that basically our Spring Boot project is not recognizing the calculator control Java. I will tell you why this happens. When first we will go into our main class, which had the at the rate Spring Boot annotation. So our project will only recognize the package and the code inside the package which has at the rate Spring Boot annotation, which is com.example.calculator, and our package controller which is outside the calculator, so it is not recognizing it. So to recognize this, we will add a simple annotation here, at the rate scan component scan. So we need to tell Spring Boot that the package com.example.controller is also to be run. So we will write the command base packages is equal to curly bracket, and inside that we will write the name of our package, com dot example dot controller. After adding our package in components successfully, it will also run com.example.controller, in which our calculator controller class exits successfully. Now we will terminate this process. Do We will do a clean package and spring. We will do a clean package. We will do a spring hyphen boot run. Now let's test the API in Postman. Let's hit send. So we change the uh, server port in the application.properties. We need to make changes here. Now let's finally hit send. As you can see, we get our add operation 5 plus 3 is equal to 8. Now let's test multiplication. So we need to give the path of multiplier. Okay, first let's take subtraction. So give the path subtract instead of add. Subtract. Now let's change the value of a and b. Uh, we will give a 4, b 6. Now here let's hit send. We get 4 minus 6, which is equal to 2. uh, Now let's test multiplication. We will change the path subtract, which matches with the which is multiply. So let's do it. Multiply. Let's change value of a and b. Let's give a 6 and b 7. Let's send. So we get 6 into 7 42. Now let's do division. Instead of multiply, let's add path of division, which is divide. So divide, hit send. We get 6 divided by 7, the answer. So division is slightly more interesting because it introduces the edge cases of dividing. First, normal division, we do everything work perfectly. Now let's use a different values. We will give a as 10 and b as 0. So Postman return division by 0 is not allowed. This is a perfect opportunity to explain why handling edge cases matters. In real world APIs, if you don't validate inputs, it could crash the application, return misleading result. This makes an API robust and user friendly. So at this point we can try other experiment using negative numbers and multiplication or division, using large numbers or decimals, swapping the orders of parameter in subtract and divide. Postman allows us to quickly test all possible scenarios and confirm that our API is working. An important takeaway here is that even a small API like a calculator can teach you best practices. Always test, handle edge cases, and ensure uh, consistency. So testing in Postman shows the practical side of API. We just don't write code and hope it works. We actively test it with different inputs and scenarios. This gives confidence that the API is reliable, consistent, and ready to use even with a simple calculator. And we see the core principle of REST API testing in action: sending requests, getting responses, handling parameters, and validating. So this concludes the Postman testing of our demo, and it also concludes our demo. So this was the final demo. In this demo I demonstrated some simple but uh, important accepts of Spring Boot REST API. So that was it from my side. I hope you liked all my demos, and thank you for watching those.